Hello and welcome to our physical sciences session. My name is Themba Ncube. Today we are focusing our attention on the revision of stoichiometric problems. We'll address a number of different questions ranging from the multiple choice as well as structured questions. So now this is the concept map in as far as quantitative aspects of chemical change, right? So you'd realize that it covers a broad aspects of of chemical change, and the questions on stoichiometry can be on any of the concepts as long as there is a chemical reaction. It could be on limiting reagents, yield, purity, it could talk about percentage composition, so just pay attention to the fact that a stoichiometric problem can be asked in whichever context of chemistry, right? And the most important thing that we also need to remind ourselves is the data sheet, right? So the data sheet forms a most important part of our information sheet in terms of responding to questions. So familiarize yourselves with the data sheet and be able to identify the correct formula. The general rule is that we do not change the subject. We copy the formula as it is, and then try and isolate the unknown as part of our responding to questions, right? So the mole concept is broad and it covers a number of aspects. It could be with respect to the Avogadro number, right? It could be, in terms of molar gas volume at STP. So we need to qualify that at standard temperature and pressure that a mole of any gas occupies a fixed volume. It could be on concentration, So the two formulae can be used, one after the other, or the second part is actually a combination of the mole calculation and the concentration to give us the formula C is equals to M over MV, right? Let's look at multiple choice. You are given 4 options, but what is important in as far as the multiple choice question is to read the question with an intention to understand without even looking at the given options. In the case that you get stuck, you can also do the elimination as part of identifying the most correct response. So this question says 10 moles of hydrogen gas and 2.5 moles of nitrogen gas. Okay, these are the two reactants. They are allowed to react to form ammonia according to the following balanced equation of reaction. So the equation of reaction, what does it tell us? It tells us that this is the stoichiometric ratio in which these substances actually react with each other, right? So pay attention. The mole is the SI unit of quantity of matter. So we don't talk mass, we don't talk volume, we talk about a mole. Because why? A mole of any substance has the same or constant number of particles. Whatever the particles could be, it could be the mole, it could be the ions, it could be the atoms, it could be molecules. So we always talk about the mole, right? So in this case, we are given the quantities in SI unit. Okay, so 3 moles of hydrogen reacts with a mole of nitrogen to give us 2 moles of ammonia. So we are told that if 4 moles of ammonia are formed during the reaction, what are the remaining moles of the reactants, right? So we want to know that after forming 4 moles of ammonia, how much will be left in terms of the hydrogen and the nitrogen, right? Okay, so we know that if we have got 4 moles of ammonia that are formed. Okay, to form 4 moles, how many moles of nitrogen are needed? If 1 forms 2. So to form 4 moles, we would need, so our ratio, right? Our ratio is 3:1:2. So for us to form 4 moles, how many moles do we need? We need half that number, which is 2. So initially, what we have, we've got 10 moles, right? And 2.5 moles, right? Okay, and then we had nothing there, okay? Now, if the change in moles that we get here, in this case, if we started with 2.5 moles and 2 of them reacted, how much of nitrogen is left? 0.5 mole, okay? Right? Okay, and then for us to to react the 2 moles, if the ratio of nitrogen to hydrogen is 1:3, so if we reacted 2, we need 3 times as much of hydrogen as nitrogen. So what do we have here? We have 6, right? Because 2 times 3 gives us 6. So if we started with 10, okay, the remaining will be 4 if we reacted 6, okay? So this is what remains for hydrogen and for nitrogen. So if we go to our solutions, okay, we know that we'll be left with 4 of hydrogen, okay? So the option is between C and D. But for us to eliminate the correct one, we would know that for ammonia, actually for nitrogen, we're left with 0.5. So this becomes the correct answer. So these other options are totally out. Then our correct option becomes option C, right? And then in the next question, we have a solution that will have the greatest concentration of hydrogen ions when complete ionization occurs. So what do we have here? We've got sulfuric acid. For every mole of sulfuric acid, right, we actually get double the number of moles of hydrogen ions, okay? And the sulfate, 1. So the ratio is 2:1 in terms of the product. But as far as HCl, what do we have? We have got 1 produces 1 mole of HCl, ionizes to give us what? 1 mole of hydrogen ion, okay? Right, and then, so in this case, this one, sulfuric acid becomes a diprotic, while hydrochloric becomes a monoprotic. But then also we have another one. This ethanoic acid CH3COOH will also give us 1 for every mole that dissociates, okay? So we need to pay attention to that. So here, if we want a higher concentration, we'll look at these options because it says the greatest of them all. So we need the one that will have, the greatest. So 0.4, if it dissociates, it will give us double 0.4, which is 0.8, right? Okay, so this one will give us what? 0.8 mole per cubic decimeter, right? While the second one will give us the same 0.4, okay? Okay, mole per cubic decimeter of the ion. The second one will also give us, if we have got 1 cubic decimeter, well, that's the volume, okay? So if we look at the second one, which says 0.4 moles of that. So if that's the volume, okay, we know that concentration is equals to number of moles over volume, okay? So we'll try and actually get as to which one has got a greater concentration. But if you realize that this gives us double the number of moles, so obviously that's what we pay attention to. So our option in that case will eliminate in the process, and at the end of the day we'll make a comparison in terms of the quantities, right? So, and as far as multiple choice is concerned, what is very important is that you read the question carefully before you answer, and also try and eliminate. It's not a simple guesswork. So that's as far as the multiple choice, as an example of stoichiometric problems, okay? Well, that's it for now. We shall take a short break for now, and then we'll come back and do more problems.